For this lesson, we will be solving exponential equations. So our learning target is that I can solve exponential equations. In order to be successful, we need to be able to identify like bases, rewrite expressions to create like bases if needed, set exponents equal to each other, and then solve for the variable. So the property that we will be using is a to the m equals a to the n. Notice how your bases are exactly the same. So if our bases are exactly the same, then we can say that whatever their exponent is will be equal to each other. So let's look at this first example. We have 2 to the third 3x equals 2 to the 6. Notice how our bases are exactly the same. And this property tells us that if our bases are the same, then our exponents are equal to each other. So let's go ahead and set the exponents equal to each other. We've got 3x is equal to 6. And then all we do is simply solve for x, and x is equal to 2. What would your equation look like? We verify that we have like bases, so then we can set the exponents equal to each other. And then we solve for x. Another example, again, we verify that our bases are the same, and if our bases are the same, then we set our exponents equal to each other. And we solve for x. Now you do. Equal to each other, so we set our exponents equal to each other. 3x minus 1 equals 11, and then we solve for x. 6x. Bases are equal to each other, so we can set exponents equal to each other. Want to subtract 3x. This gives us 0 is equal to 3x. We can divide by 3, and we get x is equal. For this one, we want to use our exponential rules. When we have an exponent to an exponent, we use our power rule, which tells us that we can multiply those two exponents. So this is 3 to the 8x power is equal to 3 to the 16th power. Our bases are the same. Set our exponents equal. And x is equal to 2. Okay, now you do. We want to multiply these two exponents. We get 6x, 7 to the 6th. Our bases are equal. So we set our exponents equal to each other. And x is equal to 1. Let's move on to the next example. We have 2 to the 3x power equals 4 to the 6th power. Notice how our bases are not the same. When our bases are not the same, we can make the same bases, just like when we do fractions. Let's say I have 1/2 plus 3/4. We can't add these together because they have different denominators. So we create the same denominator by multiplying this by 2 and the numerator by 2 as well. So we end up with 2 over 4, which is equivalent to 1/2 plus 3 over 4. And now that we have the same base, we can add them together, 5 over 4. That's the same idea with, with exponents. Now we know we have a base of 2 here. And if we look at this 4, and we want to create a base of 2, 2 to the what power will give us 4? Well, 2 to the 2nd power gives us 4. So then we can replace this 4 with 2 to the second power. So we now have 3 to the x power equals 2 to the second power, and then we want to bring down this exponent. We apply our rule for power of power. So we're going to multiply the 2 times the 6, so we get 2 to the 12th power. And now that our bases are the same, we can set our exponents equal to each other. So in this case, we have 3x is equal to 12. Therefore, x is equal to 4. Okay, now you do. Okay, if you notice, our bases are not the same. So again, we want to keep the base of 2. And 2 to the what power will give us 8? Well, we can do 2 to the third power will give us 8. So let's rewrite it. 3 to the x power equals, and now we're going to put this 2 to the third power in place of that 8 because they are equivalent. And we just bring down this squared. And now that we have, let's rewrite it. 2 to the third power to the second power gives us 2 to the sixth power. And now that our bases are the same, we can set our exponents equal to each other. So we've got 3x equals 6, and x is at 4 to the 6th x power is equal to 16 to the 9th power. We look at our bases. We do 4 to the what power will give us 16, and we know it's 4 to the second power. So let's rewrite it. 4 to the second power is replacing that 16. Bring down that 9. We've got 2 times 9. Now we have our bases the same. We set our exponents equal to each other. And x is equal to 3. Okay, now go ahead and use. Our bases are not the same. We want to keep that 5 as our base. So 5 to the what power gives us 125, and it is to the third power. So 5 to the ninth power is equal to 5 to the third power to the 6th x power. And then we have 3 times 6x, that gives us 18x. Now that our bases are the same, we set our exponents equal to each other, and 9 equals 18x. Divide by 18, and x is equal to 1/2. So this is a different type of problem. Now, when you solve this type of problem, you want to move things around to where it looks like the problems that we have previously done, where there's only one term on both sides. So on this one, we have 10 to the x minus 3 plus 26 is equal to 1,000. So let's remove this. We get 10 to the x minus 3 power is equal to 1,000. Now for this one, we have a base of 10, and this we have a base of 1,000. Because remember, any number has a power of 1. So we want to change this 1,000, where it has a base of 10, to something power gives us 1,000. And it's 10 to the third power. 10 times 10 is 100, times 10 will give us that 1,000. So we've got 10 to the x minus 3 power, and then we're going to replace that 1,000 with 10 to the third power. And now we have the same basis. And if we have the same basis, the property tells us that we can set our exponents equal to each other. And then we simply solve for x. So x is equal to 6. Okay, the first thing we want to do is want to subtract 5. Now we have our base with our exponent by itself is equal to 25. We want the bases to be the same, and in this case, they are not. So we're going to change that 25 to 5 because we want to keep the same base to something power will give us 25, and it's 5 to the second power. So we're going to replace 25 with 5 squared. And now that we have our bases the same, we can set our exponents equal to each other. 2x is equal to 2. We divide by 2, and x is equal